All right, so now let's go ahead and see what we've got here. We're going to be solving this over the interval of 0 to 2 pi. So I have cosecant squared plus 4 is equal to 6. So I'm just going to go ahead and subtract 4 from both sides. And that's going to get me cosecant squared is equal to 2. In order to solve this, I need to go ahead and square root both sides. And so that's going to get me cosecant x is equal to, I have not just square root 2, I have plus or minus square root 2. Very important that we remember the plus or minus. And so now what I'm looking for in order to solve this is I'm going to go ahead and say I've got x equals, and I have the cosecant inverse when cosecant is equal to square root 2. I also have x equals my cosecant inverse of negative square root 2. So let's recall, if I have cosecant, its reciprocal is going to be sine. The reciprocal of square root 2 on my unit circle would be square root 2 over 2. So I'm looking for, where does sine equal square root 2? And where does square root 2 over 2? And where does inverse sine equal negative square root 2 over 2? So that's going to occur on my unit circle between 0 and 2 pi at all of my pi over 4s. So this is going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that goes ahead and that gets me all of my solutions. So these are nothing compared to the other ones, right? All right, here for this one, I'm going to go ahead and divide both sides by 4. And that's going to get me cosine squared x is equal to 3 over 4. When I square root both sides, I've got cosine x is equal to square root 3 over 4. So if this is what I have, this can be rewritten as the square root of 3 over the square root of 4, which is just equal to the square root of 3 over 2. And so now here, that's what I've got. Cosine x equals square root 3 over 2. And so when I set this up and do my inverse, I've got x equals cosine inverse of square root 3 over 2. What did I forget? Plus or minus. Trying to see if you guys were freaking out about it. Okay, so I also have x is equal to cosine inverse of negative square root 3 over 2. So it's everywhere where cosine equals square root 3 over 2, positive and negative. And that's going to happen on all of my pi over 6s. So my final answer is going to be x equals, and then I'm going to have pi over 6, 5 pi over 6, 7 pi over 6, and, whoa, yeah, sorry, 11 pi over 6. Okay, so that's all my solutions for that one. And then number 14 here, oh, there it goes, number 13, okay. So for this one, I've got 1 minus sine squared. Depending upon when you've watched this, you also know that that's cosine squared, but we'll get into that. So now I'm going to subtract 1 from both sides. So that's going to get me negative sine squared x, and that's going to equal negative 1. If I go ahead and divide both sides by negative 1, that's just going to go ahead and get rid of the negative on the sine squared for me and make this equal 1. And then I'm going to go ahead and square root both sides. And so that's going to get me sine x is equal to plus or minus the square root of 1. And so then I'm looking for everywhere where sine equals 1 and where sine equals negative 1. Don't forget, the square root of 1 is 1, okay? It's also negative 1 too, but that's what I've got there, okay? So where does sine equal 1 and negative 1? So if I do that, I've got sine is equal to 1 at pi over 2, and it's equal to negative 1 at 3 pi over 2. Now, if you recall from today's lesson, we talked about our Pythagorean identities. And if I want to take that exact same problem right there, I could take this, and we know 1 minus sine squared is the same thing as cosine squared, right? So then I would have cosine squared x equals 0. Well, when I go ahead and square root both sides on that one, if that's what I do, well, that gets me cosine x is equal to 0. And when I take the inverse of that, so when does cosine equal 0? Sure enough, it's right here at these spots. So that's what I've got there on that one. Alrighty, last problem. So on this one right here, what we've got is I've got tangent squared, but I do also have a multiple angle, okay? So in this particular case, to go ahead and do this, I've got to square root both sides. So I'm going to have tangent of 2x is equal to the square root, or I should say plus or minus the square root of 3. Okay, now that's what I've got. And so I'm going to go ahead and do my inverse. So I've got 2x is equal to tangent inverse of square root 3. And 2x is equal to the tangent inverse of negative square root 3. So what I'm going to get over here, where does tangent equal square root 3? Well, it equals square root 3 at pi over 3. So I'm going to have pi over 3. It also equals square root 3. Oh, really? Yeah. It's going to be negative square root 3 at 2 pi over 3. It's going to be positive square root 3 at 4 pi over 3. And it's going to be negative square root 3 at 5 pi over 3. So those are going to be my answers going around my unit circle one time. Now, again, it's a multiple angle, so I'm going to go around the amount of times that I've got. So this is time number 1. So time number 2 here, I've got to take each one of these, okay? And I'm going to go ahead and I'm going to go around one more time. So I'm going to add 2 pi to this. Remember, 2 pi, if that's what I'm adding and I need a common denominator of 3, that's the same thing as adding 6 pi over 3. So I'm just going to add 6 to all of my numerators. So that's going to get me 7 pi over 3, 8 pi over 3, 10 pi over 3, and 11 pi over 3. So this is time number 1, time number 2 around my unit circle. And now let's go ahead and compress all of those answers. Again, I'm going to do that by multiplying by 1/2 to get rid of the 2 there. And then I'm going to multiply all of these by 1/2. So now here, I'm going to go ahead and take all of the values. So I've got pi over 3 times 1/2. That's going to give me pi over 6. 2 pi over 3 times 1/2 is going to get me 2 pi over 6. 4 pi over 3 times 1/2 is going to get me 4 pi over 6. And I'm going to keep on going. And so now I'm going to have all of these answers. And I'm going to go ahead and double check, make sure none of those are outside of my domain restrictions of 0 to 2 pi. And sure enough, pi over 6 to 11 pi over 6 are all less than 2 pi. However, I have a few things I need to do. I need to reduce any and all fractions that I can. Always. So this is going to be pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. And those are all of my possible solutions that I have. Everything reduced, fully simplified, and that's what I've got. Hopefully this helped in terms of solving inverses. Fingers crossed.